What's up, everybody? This is Mr. Wolf. We're back with another video on the unit. We're going to do a little bit of review here first of what we covered in the last unit, and then we're going to move on to a very relative topic. I almost said a new topic, but it's not really new in the grand scheme of things. So let's look at polygons. We defined what this was in the last time. Let's go ahead and review that definition so I can kind of pound it into your guys' brains, because you definitely need to know it for what's coming next. So a polygon, let me grab my pen, is a closed plane figure it has 3 or more sides, and those sides are always going to connect at an endpoint. You're never going to have something like this that doesn't connect. Also, there's never going to have curves. Let me write that in big letters. No curves. So you can rule out anything like a circle or a semicircle or, any shape with a curve, whatever it may be, a teardrop shape, whatever you want to think of. Next, we talked about quadrilaterals last time a bit briefly, but that's what we're going to be focusing on for the next couple of sections. A quadrilateral is simply put a 4-sided polygon. Now, when you think 4-sided polygon, it's really easy to think, well, square. And you wouldn't be wrong in thinking square, because a square is definitely a quadrilateral, but there's more to it than that. Specifically, a parallelogram, which is what we're going to be focusing on here. Let me draw one of these out for you. Parallelogram, such as the one seen here, it has a definition kind of like polygon that has multiple parts to it that you need to know. So it's a flat shape, it's 4 sides, and the opposite sides are parallel. Opposite sides are parallel. Opposite sides meaning this one and the one across from it, think of sides across from each other, are parallel. So if we named this ABCD like that, then we could say, well, AB is parallel to CD, and AC is parallel to BD. But there's more to it than simply that. Another fact about the opposite sides is that opposite sides are congruent. Congruent meaning equal in length. I'm sure you guys know that, but I just wanted to clarify. Congruent meaning equal in length. So we can say in this that, well, AB is congruent to CD, and DB is congruent to AC, meaning they equal the same. And using that information, you can solve different stuff. Let's say we know that AB is equal to 14 plus 2x, and CD is equal to 6 plus 6x. And we want to figure out what the x value is. Well, these are opposite sides, AB and CD, so we can set those equal to each other because they're congruent. 14 plus 2x is going to be equal to 6 plus 6x. And then we do some just basic math here. Subtract the 6 across from both sides. You're left with 8 plus 2x equals 6x. Then you subtract this 2x from both sides. And what you're left with is 8 equals 4x. And then you want to get that x by itself, so you divide each side by 4. And what you eventually get is that x equals 2. And you can plug that back into the 14 plus 2x and 6 plus 6x to solve for the side lengths. But wait, you wouldn't believe it. There is a little bit more to this. So we know that opposite sides are parallel and opposite sides are congruent, but we can also say that opposite angles are, you guessed it, congruent. So from this, we can say that angle A is congruent to angle D, and angle B is congruent to angle C. These are very important properties that we are going to repeat several times throughout this video, but also throughout the entire unit. So these are very important things to remember. Just a brief review: parallelogram, flat shape, 4 sides, opposite sides are parallel, opposite sides are equal in length or congruent, and opposite sides are also, or opposite angles are equal in length, or equal in measure and congruent. So let's talk about diagonals of parallelograms. Once again, I'll draw one out here for you so I don't have to sloppily draw one by hand. So we have this, and we think, what was a diagonal? Well, we looked at the diagonals in the last section. And basically you just draw them from corner to corner on points such as this. And as you'll notice, this separates this up into 4 different triangles. And some fun information, the properties we're going to be focusing on here, is that the diagonals of a parallelogram do 2 things. They create opposite angles. And if you guys recall when we looked at transversals, we talked about opposite angles, and one thing we always said, or alternate angles, I should say, that they're on the opposite side of a line. So in this case, we create angles that are congruent to one another, such as this one and this one, and that we'll use these for example. Let's label these as angle A, angle B, angle C, and angle D. So because this separates into these angles opposite of one another, they are congruent because it is the diagonal. That came out very sloppily. The diagonal of a parallelogram creates opposite angles that are congruent. So we have angle A being congruent to angle D, and angle C being congruent to angle B, if that makes sense. Another fun fact about this, let's erase everything we have here. The diagonals of a parallelogram do this thing called bisecting each other. I hope you guys remember what bisect means, but it means that it separates them into equal parts so that this length is congruent to that length and this length is congruent to that length. And in knowing that information, you know that you have triangles with 2 sides that are the same. You can get some information about that and solve for problems, which we will do later on, don't you worry. But those are the things to remember. Most importantly, though, that the diagonals bisect one another. Moving on, we have consecutive angles. Consecutive angles. If you guys remember what that means, basically consecutive angles are angles that are next to each other. So in this case, if we named this A, B, C, D, well then A and B would be consecutive, B and C would be consecutive, C and D would be consecutive, and D and A would be consecutive. And one thing cool about the consecutive angles of a parallelogram is that they add, we'll use A and B for an example here, they add together to equal 180 degrees. We had a phrase for that, a term for that, I should say. Think of that term. Supplementary. I'm hoping that some of you thought it before I said it. But the supplementary angles are 2 angles that add together to equal 180 degrees. And that's the property here that we're really trying to learn, is that on parallelograms, consecutive angles are supplementary. Remember that. We'll just review everything we did thus far because I know that's a lot of information really quickly. So we say the opposite sides are parallel. If you have a parallelogram, the sides across from each other are always going to be parallel. Opposite sides are congruent. Those same sides across from each other are always going to equal the same thing. Excuse me. Opposite angles are also congruent. So the angles opposite of each other, as you see in that picture there, are going to be equal in measure. Consecutive angles are supplementary, meaning that the 2 angles next to each other will always add to be 180 degrees, and the diagonals bisect each other. So let's do some examples here. Let's go back to the consecutive angles the piece and do a short example on what you can kind of use these for. So let's say that you have that this angle equals 110 degrees. This angle equals 2y, and this angle equals 5x. Okay, well, you want to find x. That's your goal here. Find x. Well, 2y and 5x are consecutive, so they equal each other, but there's nothing I can really do with that. So let's look at the other ones. 110 and 2y are consecutive. not equaling each other. Please ignore this mistake. They add together to equal 180 because they are supplementary. 110 plus 2y. I already wrote that up there. I meant to write 5x. There we go. Now I'll reread this out so it all makes sense. We want to get what x equals. So we say, well, 2y and 5x add together to equal 180 degrees, but that's two unknowns. We can't really solve for anything there. So let's take what we know about 110 and 2y to solve for y. So we get this here. We subtract the 110 from both sides. And that leaves us with 2y equals 70 degrees. And then we can bring back what we set up here. The 2y plus 5x equals 180 because now we know that 2y is equal to 70 degrees. As we see right here. 2y equals 70 degrees. So 70 degrees plus 5x equals 180. And then you can subtract your 70 from both sides. And we'll move over here. And from there you can say 5x equals 110 degrees, or x equals 110 degrees divided by 5, which in this case makes sense because guess what else you know? You know that opposite angles are congruent. So you didn't even have to really go through that extra step, but we're talking about consecutive angles, so you did. So some of you may have been smart enough to catch on to that before we worked through all of that, that 110 is just going to be equal to 5x. But we worked with consecutive angles there, so it kind of made sense to do it that way. Either way, you're learning the properties. So what can we do? How can we determine what is a parallelogram and what isn't a parallelogram? Oh, I did not do that. So let's say your friend sloppily draws something down and gives you some information about what it is. You need to determine whether it's a parallelogram or not. So let's review these properties one by one and see how you test those properties. So let's say you have a parallelogram. It looks something like this. It doesn't look perfect by any means because it's hand-drawn, but you have the information that, let me label the sides here to make this a little bit easier to see. You know that AB is parallel to DC and that AD is parallel to BC. Well, you say, well, that doesn't look like a parallelogram because it's a little lopsided, but it's hand-drawn, so I don't know. But we do have that AB is parallel to DC. Well, those are opposite sides. And AD is parallel to BC, and those are opposite sides. Well, we know a property of parallelograms is that they have opposite sides parallel. So in this case, we can say that if we know the fact that there are two sets of opposite sides that are parallel to each other, as they are in this case, it is 100% a parallelogram. You basically kind of do what we do here in reverse. In this way, we said, well, here's a parallelogram. We know that opposite sides are parallel. In this one, we said, here's a quadrilateral. We have some parallel sides. Is it a parallelogram? Well, the answer is yes. And it's going to be the same thing throughout here on these. Bear with me. We're learning the properties repetitively, but surely. So let's say you have another parallelogram. And your buddy says, hey, this is lopsided and weird, but I do know this about it. We have these sides congruent to each other. And he draws it out like that. Well, you say, well, I know a property about parallelograms. The opposite sides are always congruent. So in this case, we have opposite sides, two sets of them, in fact, that are congruent. So we can say that this is 100% a parallelogram. And I know this may seem simple, but this will really help you in testing these things. Because not only on the quizzes and tests and whatnot will you have what are the properties of a parallelogram, but you have to be able to put them to use in testing and what. So here's an interesting one. What if a single pair of sides is both parallel and congruent? Not that both sets, as in the last two properties. What if a single set? So your buddy draws this sloppy thing out and says, hey, what if a single pair of sides? So we have these here. We'll call them AB and CD. And you know these things. A, B, and CD are congruent, as I have labeled there on it. And he also says, well, AB is parallel to CD. From this, you can also conclude that it will, in fact, be a parallelogram. This is a little different one because it's not a property that comes directly from the chart, but it is information that you can derive from such. So just remember that if you have a shape, a quadrilateral, that has a single pair of sides that are both parallel and congruent, has to be both, then you can determine that it is a parallelogram. Moving on, we have a property that says opposite angles are always congruent. So if you had a parallelogram like this, and you have this angle and this angle is congruent, and this angle and this angle is congruent, and your buddy says, well, here's this quadrilateral, is it a parallelogram? And you say, well, I know that parallelograms have opposite angles that are always congruent, and this quadrilateral does in fact have sets of opposite angles that are congruent. So yes, it is a parallelogram. Consecutive angles are supplementary. We did a test on this. We've done some examples with this. So if you have a parallelogram, and ignore the sloppiness, this kind of adds to it. And you have something that says, well, this angle and this angle, we'll label them. You have this labeled right here exactly like this, and all the information you have is that, well, angle A plus angle B equals 180 degrees. And that's all the information you have. You say, well, I know that parallelograms have consecutive angles that are supplementary, and here's a set of consecutive angles that are supplementary. The thing is, here you think, well, wouldn't the rest of them also have to be? Well, here's a trick. Let's say that this adds to 110. This adds to, or well, no, yeah, it'd be 70, right. Well, in knowing this, you can say, well, if this is 110, I know opposite sides are congruent, so this also has to be 110. And if this is 70 degrees, then opposite angles are congruent, so this also has to be 70. And that's kind of how that works. It all builds together into one big thing. Then the diagonals bisect each other. Your friend draws you this sloppy parallel. I'm getting a lot better at drawing parallelograms. And they say, well, we have these diagonals, and ignore that. That I was talking too much about how good I was getting at it, and I definitely messed that up. But let's just say that that's perfect. And your friend says, well, this side it bisects that, and this one bisects that. Well, you say to yourself, this is a quadrilateral, and it has diagonals that bisect each other. And I know that parallelograms have that, so yes, it is indeed a parallelogram. And I know that was very repetitive, but these are things that are very important moving forward, especially. So what I would recommend is screenshotting this chart right here that's on screen, saving it to your computer or your Chromebook, and looking back at it. This will be your best friend in remembering these properties if I haven't pounded them into your head already. This video is a little bit short, but I hope that it helped you. I hope you can remember these, and once again, review these properties that are very important, and I'll see you in the next video or class, whichever comes first.